Hey there once again everyone. I know it's been a while since my last video, but it's just things in life get in the way. Sometimes it was work, being somewhat busy there. Other times just personal things going on, and for a while there, even though I did have some days off from work here and there, sometimes I just didn't feel like, recording, even though I had everything ready already for this next video, which I've been meaning to do actually for a very long time, like I probably about 2.5 months now, and I just couldn't get myself to come over and record it. So this one right here, I'm gonna do what I'm calling an introduction to LEDs, just because I think they're very useful to have, for your home cockpit, and also it's one of the questions I get asked the most about LEDs is what value resistor should I use. In this video, I'm not really going to show how to connect them for the purposes of using them with RealSimControl and SimVimX, but I'm just going to talk about, play around with them a little bit using different types of different values of resistors and different lights and everything, so you guys can see how each one of them behaves a little bit different, so that you can see that when people ask what value of resistor should I use, it's not really an all in one answer that's going to work for everybody, because even in the packages of LEDs that I've gotten, they behave very differently with the same value of resistor. So let's go ahead and get going. Okay, so as you can see here, I have a lot of different LEDs here on this little piece of wood here. And so you can get them, all the way from the little tiny surface mount LEDs like the ones right here on the Arduino Mega. You can get some 3mm ones like these. I believe these are the standard 5mm ones. You can get squared ones if you want to. These right here, I think they're 10mm, but they look very big, so I don't know. And then over here, I just have a bunch of them that I already pre-wired with different values of resistors for the experiments that we're going to be going over today. And then of course you can get them in push buttons here with different color lenses on them, so that you can have displays that have something lit up when you press them or turn them on and off. And then these right here, like this red one and this yellow one, they're not buttons, they're just actual LEDs. So you can just get them like that too. And of course you can get them like in Cori type switches like this one, which you probably can't even tell, but there is a red LED in there. I really wish I could find these in green, but I have not really been able to find them, only with red LEDs. Alright, so whether you're using, regular LEDs or push button LEDs, whatever they have, the different shapes and colors, or the Cori type switches with an LED light built in, it's all the same thing. The method of connecting them is going to be the same, except when it comes to using the DM13A LED driver. That's going to be a little different, but that's going to be covered in a completely different video, so I'm not even going to get into that here. Alright, so let me clear this area here and then we can start playing around with them. Alright, so I'm not going to go through all the details about LEDs. What I'm going to do here is the basics. As we all probably know, different types of LEDs require different amounts of voltage in order to light up. That minimum voltage is what's called the forward voltage. So the reason that we need to use resistors is because obviously if we're putting in a certain voltage, like let's say on my Arduino here, and we can see that I'm getting 4.93 volts coming out of the Arduino. So if we try to put that amount of voltage into most of our lights, they would probably just burn out. So that's the reason why we need to use a resistor, so that we can basically limit the amount of current and therefore the voltage that is getting to those LEDs, so that they don't burn out. So I'm gonna go ahead and put this here. I believe I wired them with a resistor on the positive lead. Alright, so I'm not sure if you can tell right here. Yeah, you probably could see it right there. So this light right here has a 270 ohm resistor, so that's the way it looks. And this is not a very bright LED. These are just normal. I don't know if you can see them from the side. But anyway, so this one here is good enough with 270 ohms. It looks good to me here. It's obviously a lot different looking at it in person than in the video. So that's the red light with 270 ohms. Then I got this yellow one here. So let's see how this one looks. There we go. Oops. Actually, it looks a little bit more like orange to me than yellow. But hey, it's called yellow, so okay, whatever. So that one looks pretty bright. That one actually looks brighter. So depending on what you wanted to accomplish in your cockpit, you would probably want to put even a little bit higher resistor on this one than 270 ohms. I believe the green one here, this one only has a 100 ohm resistor because this is a very weak green one. And you can probably see right there that it is very dim. But if I didn't put a resistor on it, I think from when I was playing around with them, these were getting burned out because it's just that type of LED. Now, let me show you what I mean by different types of LEDs. This one right here, I have, this is a super bright green LED. It's not the same as this one. It's a completely different set that I got. And this one right here, they actually, I think they didn't get burned out with 5 volts direct, which is really weird. But you see this one right here, this is with a 270 ohm resistor. So as you can see, it is extremely bright. It's very, very noticeable, right? So that's using the same resistor as these other two right here, you know, but it's even higher than this one, and you can see that it's much brighter. So that's why I always say, you know, there's not a one fits all answer for this. Now this green one right here, this is the same as this one, but I'm using a 2.7 kilo ohm resistor, just so that we can see, you know, that it takes that much to make this light be not so bright. So that right there, you can tell it's more manageable. It's still very bright, but it's not even close to how it was before. Actually, okay, so here I have them side by side, so you can see the one with the gray wire is 2.7 kilo ohm resistor, and the one with the red wire is 270 ohms. So you can see the difference in the brightness that makes. And it's the same LED right there, those two. Okay, and finally we have these white one and this blue one, which are also very bright. I believe the white one here has a 1.5 kilo ohm resistor. So let's see how that looks. Yep, it's still pretty bright. You see that? I mean, especially when you look at it head on in the camera. So that one right there would probably be better with a like a 2.7 kilo ohm, just like this green one, because it is just about as bright. Okay, and finally this blue one here, it has a 220 ohm resistor, and it is also one of those very bright ones. It's not as bright, it doesn't look as bright as the green one or the white one, but it is. It's actually one of those very good ones. So for all these lights, obviously, you know, I would want to use probably 2.7 kilo ohm resistors or even higher. Okay, now we're going to change it up a little bit. I got this power supply here that I made when I was taking some electronic classes in a community college. And it's a variable voltage power supply. I can vary it from 1.24 volts, and it goes all the way up to about 14 and a half, I believe, 14.2. So we're gonna just basically play around with it, and we're gonna see what happens to the LEDs when we don't use a resistor. Alright, so here I have a green LED. I think this is one of the normal ones. It's not a super bright. So as you can see, I have 1.24 volts right there, but it's not doing anything with the light. So if I start bringing up the voltage there, you can see that right there, I barely start seeing a little bit of light at 1.91 or 1.9 volts. So 2.2, this light actually, this light might already be damaged. You can see that it's lit up right there, but just barely at 2.1 volts. And if I go much higher, it starts turning yellow. So right there at 2.7, I could already see that it's starting to burn out. You probably don't see that on the thing, but if I raise the voltage much higher, there, it burned out. So even with 3.6 volts, it already burned out. So you can see why, oh, it smells very bad. So you can see that we would not be able to connect that directly to the Arduino because that's about 5 volts. Okay, I'm gonna try a yellow one now. Alright, so let's see what happens with this one here. There we go. So right around 1.8, you can see that it starts lighting up. At 2 volts is nice, it's pretty bright. At 2.3 is very bright for me here looking at it directly. See, this one's it's already starting to turn a little bit different color at 3.7, but you can see that it hasn't burned out yet. It still looks good. 4 volts, and it's starting to look like it's getting damaged right there. 5 volts. Yeah, so this one would actually survive 5 volts. And right there at 7 volts, it's burning out. 7.5 volts. Wow, this one actually could take a lot. Yeah, I think I permanently damaged it though, even though it didn't burn out catastrophically like the other one. So, what a difference between one color of LED and the other one. Alright, so this is the flat side. So that's the negative. Alright, so here's the red one. So let's go ahead and start bringing it up. There, 2 volts is starting to look good. Right there around 2.3 volts is where it looks probably the best. It looks different in the video than in person though. Alright, so now if I bring it up a little bit, I could already see it starting to change. See, but it's so funny that this one is not dead yet. You can still see that it's alive, but it doesn't look good anymore. Instead of looking better or brighter with a higher voltage, it looks dimmer because it's probably starting to burn out. Yeah, so once you go past a certain voltage, like right there, you see it's never coming back again. It still shows a little bit of light in there, but it's not going to come back anymore. So, there. Now it burned out. You can even see the smoke. And that was a whole 14 volts before it started burning out. Alright, so this is a 270 ohm resistor on the super bright. Alright, so there's 2.55. There's 3 volts. There's 5 volts. And it's not even showing any signs of damage yet. And it looks really bright. Well, there's 7 volts. And it's still just extremely bright. I'm sure that, you know, if I were to use it like this, it was going to cut the life of it. But it looks very bright with 7 volts. And this one is not damaged yet. As you can see, I can go back and raise it and lower it. And you can also see right here what the difference in voltage makes, you know, to the brightness of the LED. Okay, finally we're gonna just see how much current the LED draws. So I have my multimeter here, and I have connected the power leads from my power supply in series through the multimeter and through the LED, and we're gonna see how much current it draws. So right now I have it on 200 milliamps. So I start increasing the voltage here. And I'm gonna keep an eye out when it starts showing some. Okay, right there is already showing a little bit of light at 2.2 volts. But as you can see, that's barely, now that's 1.8 milliamps right there at 2.36 volts. and then that's 4 milliamps at 2.48. Okay, so right there we got, remember most of these LEDs can handle about 20 milliamps. So that's going to determine, when you're going to burn them out. So right there you can see I'm at 2.9 volts pretty much. And I'm doing 17 milliamps right there. So as I increase it a little bit more, so there we're already above the 20 milliamps right there. So we're technically past the point where that LED could start getting damaged. And I think this is one of the super bright ones. So I know that it could handle a lot more just because I know. So you see right there it's already 50 milliamps. So you remember how on the website it talks about how you should not try to run no more than 3 to 400 milliamps draw out of the Arduino. So you can imagine if you have um, a few of these through the Arduino at maximum brightness like they are right now, you can already be drawing, let's say 6 of them can be drawing over 200 milliamps. I'm sorry, 300 milliamps. So that's why it's very important that, if you're only going to run a few LEDs, then it's okay to do it through the Arduino. But if you're going to run, like let's say 10 of them, unless you keep them at very low amperage, that let's say you're going to do like, you're going to try to use a resistor where you keep them like, let's say right about right there, that's 12 amps, 10 amps, milliamps, I'm sorry. That's even 5 right there. So, I mean, if you do some testing and you figure out like, okay, I'm not drawing a lot of current, then it's okay. You can do as many as you can without going over. But just remember, you're also gonna be powering your other things, like the switches and everything. You're gonna be powering the little chips on the multiplexers or other devices that you have connected. So you have to keep all that into account. All right, so now I'm just gonna go ahead and take this one off, and I'm gonna put the one with a 2.7 kilo ohm resistor. So there, now I got the one with a 2.7 kilo ohm resistor, and you can see that I'm still at the same voltage, but it's only drawing 0.2 milliamps. So I have to increase the voltage. Let's see how high I have to go to get 1 milliamp. So there, I have to go to 4.9 volts so it can draw 1 milliamp, because the resistor, is holding back. It's resisting. So in order to get this one to draw, wow, it's really difficult to get it to draw any current. Look at that, I'm already at almost 10 volts right there, and I'm at 2.8 milliamps. So it's showing what a drastic difference using a resistor makes, and especially a very high resistor like that one, which is 2.7. Well guys, I think that's gonna be pretty much it for this video. I just wanted to play around with LEDs a little bit and give you guys some kind of a visual idea of the different voltages that each one takes, and what effect using different value of resistors for each one. So you play around with them yourself, when you get your LEDs, figure out how they behave with certain voltages, and then go from there. So sorry it took me so long to get this video out. I have some other ones on LEDs. I want to do one on tricolor and bicolor LEDs, and I definitely want to do one on the DM13A, even though I talked about it a little bit on that other video when I did that kind of like a MCP panel setup, but I didn't really go deep into the wiring of the DM13A. So I want to do that on a separate video. And then and I want to do the next one will be on direct connection. So basically just connecting the LEDs directly to the Arduino. Alright guys, so hopefully that will be much faster than this one was. No, I promise it will be. That was extreme. But thank you guys again for watching, and I'll see you on the next one.